welcome to this session. Sorry, going to start the session. Hello, everyone. This will be a combined session. It was supposed to be 2 sessions, but we think they are rather short, single sessions. So the first part is how we are going to port Opti to another platform. Since we now had it open sourced in the beginning of the summer, the natural step was trying to look into other platforms and how should you then do to be able to get it up and running. And Sonny here from Allwinner, he has been trying to do this porting to Allwinner's A80 board. And that's an that board is an A7-A50 board, as you can see, being built, and it's quite powerful. And the form factor is quite nice. It's a tiny little board with a lot of features and everything, so it should be interesting to see whether we actually can get hold of this one. These are locations you have probably seen it before if you have been on our sessions where you do change source code. And these are the basics just to get it up and running to compile the Opti. In A80, they have partitioned the memory like this, so they have 20 meg in non-file system area where you have the bootloader, the initial bootloader, and you put the Trustzone binary and the U-boot. It will be loaded from ROM code to bootloader 0, which will load the T binary in secure environment, and then it will switch over to U-boot, and U-boot will load the kernel. And this is one of our favorite pictures, looking a little bit different. On the left side, you have the normal world, Linux, you have the client applications, the library that talks to the secure environment, and the T library. And on the right side, we have a similar setup, but it's one on the secure side. You have fast applications on the top, and you have an API that those can talk with, and below that you have the actual core functions and the hardware abstraction layer. And in this, what we're trying to abstract as much as possible. So when we are porting this to another platform, we don't really have to touch anything of the things on the left side. It's only on the right side that is in this red little ring that you have to do changes to. So that means that of the 3 different gits that we have source code in, it's only one of the gits that you need to do changes.
So, did you not have to do some changes somewhere to install a secure monitor? You can probably just repeat that. Yeah. Did you have to make some changes in the firmware somewhere to install the secure monitor?
Sonny?
Did you need to do any changes in the secure monitor when you did this porting activity?
No. It just modified the platform level codes. No need to change secure monitor. Secure monitor is the standard, just save context and restore context. It's not relative to platform.
So you changed your bootloader to load it, but you didn't have to change any of the code within it.
There's a monitor integrated with the OS on V7. So on V7 is the monitor code part of the same binary as the actual TE.
Yes, the secure monitor is integrated. Yeah.
Okay, so there's no sort of platform-specific runtime firmware that's left.
No.
Okay.
So what has been done is that initially we had it running on ST's on board, and we have abstracted all the platform-specific part into a code called platform and the name of the architecture. So suddenly he more or less just copied that one, and it contains these files. We go through the files shortly, slide to slide here now. It's make files and some files containing addresses and such. The first one is just a configuration for the main file that decides which compiler we are going to use, what type of architecture you're building for. The linker make file simply points out the linker make script and tell you where you should put your files that are produced, and if you have additional flags, you can put it here also. The linker script itself tells where how your binary will look like when it comes to sections, and you decide how memory should be put into the system. There's a file called systemconfig in. That one will be replaced, but that one contains addresses for your RAM, where you should put it, how much you have the cores, or running single core, dual core, and so on. So you have to state that one in this file, and the different stack sizes. And the new file that is going to be used, if you're looking into the source code today, you will find two folders. One folder that has both this system config in file and this platform config.h. In Virtual Express version, it's only platform config.h.
Why would a platform use different stack size?
And you define it different for that.
Why would the stack usage be different on different architectures?
Could be, constraints.
I guess that's probably not such a need, but we are still well, trying to define exactly what's supposed to be platform specific and the font, so we will probably face it up.
I presume it depends on the driver complexity for the platform. You may have a substantially complex driver that requires larger stack than is default.
Yes, probably.
That's probably the only reason.
Just to let you see a quick overview of what it contains, is about 100 lines of code, so it's, like you said, you have a configuration for the key keywords, stacks as we just said, and then you have the memory coming later on. And here you can see this also Regency QW in this case. So it's actually containing two different variants here. So it isn't that big. So
I don't know what's getting out of the reporting topic, but is that kind of a candidate for we have the same default values in config, only change those whereas over.
I mean, that's what we have tried to do. We have tried to abstract as much as possible, and of course you can always continue trying to remove things into more generic parts, but I think this is quite, it isn't that much actually to add to be able to support it to someone. The memory map today is divided into two different parts of for A80, so it's, you have one secure and one secure, and that is divided in sections for first applications and the T4 itself, and then you have the public RAM that you can use to share between the two cores also.
Sorry, does the trusted application itself set up those bits of RAM as secure? Like set up a TZC400 controller?
Yeah. Yeah, it is the trusted controller that is in use here.
And it's self-securing.
Yeah.
So, what was the question again?
Does the TE set up the security on its own RAM?
And then we have showing how it will look like in a file when you actually define it how it should look. So you can, here it can state basically if you want to have secure, non-secure, and so on. You can also done it for IO devices. And that's it actually. To what you need to do to port it. It's take this structure, update the different base addresses, and hopefully it should run. And when you're running it, what will happen in the first step when you pull the reset is that you will jump into the main function here is this. You have on the right side inventory, and that one will initialize caches and review. And then it will jump to the main function. It will register a couple of handles for the different FAQs, standard calls, abort, and so on. And when you are up and running and you get a SMC call in the secure world, you will get down for a couple of functions and you will check if it's an hierarchy or not. If it's not, it will go into the different handles that you just registered, and then it will call the function that is actually supposed to be called. And here are some documentation and general information you can find about this. That's it. Short introduction. Any questions?
So, where did you run the TE file? Which bootloader component?
Sorry. Where did you run it from? Which bootloader component?
Is it from U-boot?
It was U-boot you were running. It was U. It was U-boot.
Yeah. Just want to check that.
It's in very, very small code.
And U-boot was running in secure supervisor mode.
That it's not being run from ARM Trustzone firmware.
This is V7.
This is a
Sorry, this is for Allwinner A80. Yeah, so it's different.
Yeah. And did U-boot have to be running in supervisor mode? Secure supervisor.
U-boot is running in non-secure mode. The first bootloader state level while running secure mode. It will jump to TE world where initial the secure as, and when the secure as TrustZone initial finish, it will jump to U-boot. U-boot where normal world. If U-boot will use some security service, it will go from SMC command.
Yeah. So in order to jump to it, you jump into secure mode in the TE.
Yes.
You had is platform QEMU. How much? I mean, QEMU doesn't do Trustzone. How much is QEMU useful to play with this stuff?
Actually, it's very useful. We can run most of our tests in QEMU.
Well, how's it just so how is the communication to achieve when you have no Trustzone?
Well, we have a QEMU with Trustzone patches.
So those are upstream?
No, it's not upstream yet.
We have Greg sitting there. He has been taking care of the patches that's going for upstream in QL. Maybe it's Trustzone.
Okay, cool.
And those patches is what Jens has been using lately when he had tried to run QEMU. And you have been running and successfully actually more or less the complete test suite have passed. So,
yes.
So that's something in the near future.
Which platforms are very supported?
Today it's we have it running on ST's Orly board. It's Dole B2020, B2021, H310, H410, and we have it ongoing on Allwinner A80 now, and we are going to start porting to Huawei's HI3760. We have it up on FVP, foundation models, fast models, and QEMU. And the next step in the near future is Juno. So there are a couple of different right now.
The ARM Trustzone firmware-based board is also available on one of these platforms.
Yes, yes. In the FVP variant, it is using ARM Trustzone firmware. And for Juno, obviously, it will be ARM Trustzone firmware.
Thanks. And I guess if I needed to look at the changes that are needed in the ARM Trustzone firmware section to run with OPD, where do I look at?
You can find it on GitHub. It's merged now. So it's on the master branch on GitHub for ARM Trustzone.
Thanks.
Are the QEMU patches on GitHub?
No.
Where are they, Greg?
They're not reviewing. Oh, no, no, it's just the process for the issue.
You can play around with FVP. It's very easy to set it up now. We have written a script that downloads and sets up everything, and a couple of people this week have tried it. So send me an email and I will point you to the link.
Yeah, I got a stupid question about what's the implication for the Linux that's using the TEE driver in non-secure mode? Is he just completely the same as a Linux that's running himself in secure world with none of this business? Or are there some changes necessary, implied, that he can use any of this?
The Linux driver itself is more just like a transporting mechanism between normal world clients and the secure world. And there are some things that, I mean, currently we're trying to refactor the driver, and that will contain a generic part and a specific part for the different hardwares.
I'm asking more about the actual Linux kernel that's running non-secure itself. So if I had that kernel running without any of this, and he was still himself, had secure attribute, and he was able to touch anything, what would I have to change in that kernel to make him happy in this non-secure world using TE driver to get his secure jobs done? Is there anything, or he's exactly the same?
No, it's significantly different because Linux is just normal role Linux. It doesn't have access to anything that's been marked as a secure device. It has to then, instead of talking to the device directly, if it needs, secure variable storage or something, something that has to be done by Opti, it's a communication protocol. So it sends a message, and Opti will do something, and then you get a response.
I understand. I meant more. There wasn't much overview in this presentation about where this fits in the larger kind of world. So I'm wondering if there's some changes necessary for Linux to run at all. I don't mean to pipe the access through Opti, which obviously you have to do if you're going to do that. I mean, just to get it to come up once it's been prepared like this in non-secure. So GIC is all completely happy and unchanged?
You need to do changes to the gig.
No. Actually, I think no changes is required because, I mean, the jig looks like it's just a plain non-secure jig, for instance.
Okay, thanks.
I have a question.
So is it fair? Can I just follow up on that? So, is it fair to say that if you got Opti on a system and you boot Linux and you happen to not have the Opti Linux driver, you just don't have that communication channel, and Linux just pretends it doesn't even know about it. It doesn't even know it's there.
That's right.
Is that answer? Okay.
So let's say that I find a time to fire up QEMU. Is there a wiki that describes the steps on how to boot the whole affair and make sure that, how to load the software, and once it's loaded, how to make sure that it's actually working? Like a proof that what we have here, a minimum like health check, to see that I've really done it.
If you can do that.
I'd like to.
Yeah, sure. I can show you.
That'd be lovely. Or
No, not QEMU right now, but FVP. We can.
Yeah, just a how to. that people can go to and look at the steps so that they can take their work, put it on there, have a healthy implementation to start with. This is how it looks like, and then they can start putting that onto their board. I think that would be a very good way to broadcast the technology and make it more available to people. I would certainly be interested in reading that and trying it on my own.
Yeah, but that's, we have regarding documentation, we have a to-do list, and we have some branches that contains documentation. That's in this presentation I pointed out to one that said exclamation mark saying this is still not in the official, but it's in the pipe, so it's
good, because I will certainly do that. I'm interested. I'd like to see. I've always been interested in that. But looking at the presentation here, it seems like you have good material. On the flip side, it's hard for someone from on the outside to get in there and, you know, pick and choose which instructions and what should be done.
yeah. Yeah, it is quite tricky. I mean, we have one Google document today where it was Jens here that initially wrote it. It contains basically all the instructions you need to set it up, but it's still quite tricky because you need to download a couple of gits, you need to have correct tool chains, and you need to point binaries between each other. So that's the reason why we wrote the script last week. So you should just run this script and it will download everything for you. And one of the guys I talked to in the beginning of the week, he tried it out, and he had one problem. It was some package that he needed to apt-get. He apt-getted that package, run it again, everything was working. So.
Because I can see how you can easily get lost setting it up.
Yeah. Okay, then let's continue with the next session. That is about, this is an outcome from, we had a sprint in the beginning of the summer, and we identified a couple of things that we would like to look into in the near future. So this starts with the cryptographic layer in Opti. Today you have as a low-level cryptographic engine, there's libtomcrypt running. And we would like to make it possible to change that to OpenSSL, or if someone have a hardware dedicated IP instead. And Jerome here on the corner is currently doing this work. So that's, I think it's a month from now it should probably be available on GitHub.
Yeah, so the batches are on GitHub, and actually the code. So the batches are on GitHub, they are pending review, and the code was tested on Foundation V8 platform, and basically we have the same level of features than previously without the internal API, so it should be okay. Now the next step will be actually, as you said, to try implementing OpenSSL. Then we will see if the code is actually that does actually fit the need with another provider. Thanks.
So is for that option, is that OpenSSL as a preference, or is it because make a transition to OpenSSL because it solves the problem considerably better?
No, in our case, what we have in our use case, we actually prefer to use libtomcrypt, but a lot of people like to use OpenSSL, so we would like to open up the possibility for them to use it if they need to.
Okay, so do we have use cases for that? Because one of the things that I'm concerned about is if we're going to do something like make the crypto library pluggable, what problem do we immediately solve in doing that? Aside from, it's an option to implement one or the other. I mean, I guess my question would be is, if we've got, what are the concrete reasons that some users prefer OpenSSL?
I don't think it's used. I mean, it's going to be built on pluggable, not runtime. And it might be that you've got dedicated hardware IP that does cryptography.
Well, yeah, that makes sense. I understand that one.
So you'll need to have a framework or an API that you have something at the back behind it, and then you could say, well, you can plug it into OpenSSL, or you can plug it into libtomcrypt. Or
Okay, so this is for,
you need abstraction to be able to do hardware versus software.
okay,
And
so.
then you could always use then which software.
So OpenSSL is the test case, but what's far more interesting here is the hardware elements.
Right. Yeah, OpenSSL is a way to validate the abstraction.
Okay, that makes sense.
You want to result it or to bring it to OpenSSL voluntarily? I mean, I don't expect anyone reasonable to bring it to OpenSSL voluntarily. Yeah, I don't expect anyone to voluntarily move from Lipton Crypt to OpenSSL because, well, I mean, in terms of code quality, well, Lipton Crypt is maybe not the best, but OpenSSL is worse for the time being. Maybe after the audit will be complete, then it might be an option, but today certainly not. I mean, there are too many buffer overflows and so on inside.
So I just thought that. Thanks. I'm just trying to understand what other activities are going on within ARM in terms of implementing maybe the ARM-A80 cryptography extensions, whether they're already under some kind of API, whether that's OpenSSL or some other abstraction layer, and whether there's something to fit together there rather than having lots of different abstraction layers with in different projects trying to plug together. So there's probably going to be again commonality in the trusted firmware where we want like cryptography stuff there. So we want to make sure we're all using similar abstraction layers with the same different kinds of plugins underneath.
It will be tricky if we should have common layers between this falls under the internal API in global platform. So you have global platform and then you have another layer and then you have the actual engine that is doing the job. So in this case, if we should share it, I don't see that's possible.
Okay, but maybe there's a case just for portability purposes having multiple abstraction layers. But,
I mean, this is, if you're running a Linux system today, you have in the normal world you can run OpenSSL directly. That's it. You have a crypt API in the Linux kernel that you can run, and you have a crypt API in the secure world that you can run. So you have different places where you have crypt APIs. So.
Okay, I think it's just about keeping in touch with everybody doing this sort of stuff, so we're not duplicating efforts.
Okay, it's an interesting comment.
The cryptographic extensions are available not only in 64-bit ARM-A8 but also 32-bit code. My guess is OpenSSL may have now got patches for 64-bit acceleration, but they may not have 32-bit acceleration when running on ARM-A8. And that's certainly at the moment Opt is running as AR32 on V8, and so if you're looking into cryptographic extensions and accelerating it, you'd actually want an ARM thumb implementation of that code, not an A64. So it's not quite, although OpenSSL has it, it's probably not in there yet in the shape that you need it.
I mean, what we want to use here is that we want to make use of the things that ARD did for OpenSSL. See how much we can reuse.
That might be porting to the 32-bit OpenSSL build as well.
Yeah. Okay, more question about the cryptographic? Then another thing that we are trying to follow is what is happening in global platform, and they released updated version of that's called the internal API this summer. Mainly, it's about adding elliptic curve cryptography, and they have been removing a couple of times, they have been removing features regarding objects, and then regarding the time, they have some more requirements so that you should support. There's a slide about that later also. Secure storage. In the internal API, you have secure storage by default. And global platform in version 1.0, they didn't mandate that you should actually encrypt something. Secure storage is that you should be able to store something from the secure world. And that functionality is in place today. So you have calls that you can initiate from the secure world, and it will store a file on the file system in normal Linux environment. We would like to add some kind of encryption, so you can make that possible by default without thinking about it. We have an implementation of RPMB that is 70–80% done, I guess, something that we would like to finalize. And streaming, when you have video content, you can leverage this functionality also. And key provisioning is, of course, something that people are interested in, but all boils down to that you need secure storage functionality. That is in place. No questions?
So, going back to secure storage, so what are for what you've currently scoped out for the work, is it primarily just to conform to the global platforming ABI or API, or is it, are there other use cases that you're wanting to support here?
These are our use cases also. RPM based global platform, for example.
Okay, that's a feature. So use cases, how is it going to be used? Why are we doing this? I mean, we're going to have a whole other conversation about that later, and I can think of situations where we would want to use it for, key storage and secure boot, and there's some of those scenarios. What I want to know, are there other use cases that are wanting to make use of this that we can make sure we pull and make sure we're testing these things when we go to do this, and also so that we're thinking about it when talking about how these services should work.
I mean, you have the DRM use case also. If you have a file downloaded to your system, you need to have that in a secure place also, and that is one of the use cases that you have here. You have to have in mind that the things we are doing right now, since we released this, is trying to expose a lot of services. It's like if you're creating an Android application, for example, you have a bunch of services and APIs available, and it's a little bit up to your imagination what you should do with it. And it relates a little bit to this also. We need to have some APIs to be able to support something.
Okay, so this is where I'm going to be a really big pain in the butt, because I'm going to push on this over and over and over again. I don't care about features. I don't care about how many things that we can make this do if we don't have the use cases behind them, or if we don't have, that's how we figure out which of these features that we're talking about are the ones that we should really be focusing on. And are we spending the time, do we have people working on the testing in typical ways that the features are actually going to be used? We can come up with great gobs of nice things that we'd like to see Opti do, but that means very little to me if we can't line those up with problems that it solves. So that's why I'm going to be painful on this, and for every one of these slides, I'm going to talk about that, just because I want to kind of hash it out and say, right, so why are we doing this? What are the other pieces of software that we need to pull in while you're working on this to make sure that it's actually using it and it's useful? Next question's over there.
I would say from Texas Instruments' point of view, secure storage is a #1 priority. We get asked that all the time. Other than secure boot, the next feature is, can I save some stuff on my flash that's encrypted with a key that's protected from hackers and so forth.
Okay. So can you elaborate? What are the use cases that you want to do this for? How are you going to be? You want to do secure storage of files. How do you want to use that? Are you expecting a service exported from that's accessible from the Linux file system for application to use? Are you expecting something internal that the kernel is using?
the way we've done it in the past is use the kernel file system, having the secure side provide an encrypted blob that goes out to the file system. So basically, that would be sufficient for our purposes.
Okay. Right, so that's going to be, how do we then expose that? Do we have the communication protocol, do we have the right drivers in Linux to do the...
Yeah,
can we send that to the lab? Can we get that into mainline on Linux so that that's properties there? We've just got this service.
Well, from a use case perspective, in fact, secure storage will be used by trusted applications. As you said, well, it's mainly about key management, but it's not key management only for the boot, but for instance, for mobile financial services. We have, for instance, Visa within Global Platform, who already said that, well, once there is the Global Platform certification process put in place, they will require that. And of course, in order to get certified, you need to have a robust implementation of secure storage. So, content protection actors are seeing the same.
Okay, are there, do we have what we need to make sure that those things are being, that what we do here meets what visas, like visa content? What else do we need to be doing testing on?
Well, what they will require, what they say at least to Global Platform, is that they will require the Global Platform certification stamp, which basically means you have implemented the APIs and you have, the solution has been evaluated for being sufficiently robust by independent laboratories.
Okay, let's jump to the next one. Secure time, it's also coming from Global Platform APIs. You should have the possibility to get the time both from the RE and the T itself. Today, the current implementation, we get the time from RE. That means that it isn't secure. However, this is something that you should be able to do, so it's not something that you have done just as a substitution. Double part is something that is quite different depending on the hardware you're running. So we're going to implement it. It's actually almost done. SY sitting for there. Last week merged patches for this. So now we have a time API, which makes it possible to get a secure time from different hardware you're using. And as you can see, there's a little bit tougher requirement now in the internal API compared to the past. You cannot deviate too much from the time system. Questions, Grant? Reduce memory footprint. Today everything is just enabled more or less when you're building Opti. So this one is simply just trying to divide it up in more structured way so you can compile time flags. Disable functionality that is interesting for your use case, so to say.
Sorry, just a quick one on that point. Do you anticipate Opti or the applications getting so big that they need to use DRAM and partition that? Or?
No, but in the case, for example, if you run on chip, you maybe want to reduce the size a little bit more. So. Multiple TA support. Today we're only running one TA at a time when you're in the secure world, and we want to enable so you can run several of them. The solution today is prepared with threading support. It's not activated. So even though it looks like you're running several different threads, it doesn't today. But it's prepared. And we have the paging support. This is something that has been enabled in all the products, but we would like to enable it again. And this also relates to the on-chip. If you have some constraints there, you can use running on-chip and then enable paging support. And it will help a lot. So, for the PSCI parts, We have made sure that you can, as stub functions today, you can register this CPU on, off, suspend, and resume, and implement if you need. The hours are handled by ARM Trustzone firmware today, so even though it says implemented PSCI version affinity for her, they also take care of CPU on and so on.
So you're doing that for the 32-bit space, or is that just for the RTF 64-bit?
We will get called we register the handler, so when you get an SMC call, you can get down to these functions that you have registered for these.
So yes, for the 32-bit.
Yeah.
Yeah, just asking.
Yeah. ASLR, coming more about that in the next session we have in a couple of minutes.
We can talk about, is this in relation to normal world or is this in relation to Opti itself?
This is to Opti. Today it already exists in normal world of user space and Linux, and I guess it's Nicola here that added some of those parts. We would like to enable it. It could be tricky to enable it. In the current setup, there are some problems that we need to solve. We don't have the solution yet, but we think it's something that could be valuable to have.
Just on that point, I guess for that to be useful, then I guess you want the firmware underneath to have the same feature. Or is, do you think, run independently and still be useful to? I'm thinking of the RVA space.
Yeah, I can't argue against it. I mean,
of course,
it's
seeing your requirements on trusted firmware.
I mean, you don't have to do everything at the same time. It started with adding this support in. Was it normal world user space? They started with it, and then the Linux kernel. So they are adding more and more places.
I think it's reasonable as well to take a look at it just from attack surface of, we're working on it with Opti, and we don't have to try to do all of those things at the same time. The ARM Trustzone firmware attack surface is much smaller.
So, what does the audience say? Does it sound something like could be useful?
I'm just making the point that if software's well written enough, you have software overflows and things like that, then you shouldn't need this. But it is belt and braces.
All C programmers write perfect code and never
exactly.
This is, we've had the same basic kernel. Of course, the kernel's much larger. It's hard to say when ASLR helps, except when we absolutely, we can't say that it's helping us, but we can really say when we've had a failure that ASLR moved on. So it's like any of the security approaches that we do. This is trying to layer up protections, and it's how much priority we have the engineering effort to spend time on making this work.
Yeah, we don't get reports of failed hacking attempts due to ASLR being in use. Yeah.
There are critics already today in ASLR in the Linux kernel. It doesn't have too much randomness actually, so there needs to be done work in the kernel also to get it bulletproof, so to say.
Going back to Grant's point, so this is probably a case where when the customer is asking for it rather than just sort of do it because it's interesting.
I'm being really iffy about this one just because it's not an easy one to answer.
Do you look at the certification requirements that are being used by the various bodies?
So is there, what does global platform require? Does it make any statements about the implementation aside from don't make your implementation sad?
Yeah, well, global platform is completely technology agnostic. So, I mean, for instance, it doesn't mandate Trustzone or some specific technology. And second, the way you protect your implementation is up to you. The things are, well, I mean, the protection profile, so the document that defines the security requirements is mainly about all trusted applications should be isolated one from another. Of course, the TE core itself should be isolated from the trusted applications, and the whole of the TE, including the trusted applications, should be protected from the rich OS, I mean, from the rest of the world. How you achieve that is, well, your choice. And, well, I mean, there are choices that will make it maybe easier to get certified. But there's no mandate to use this or this specific technology.
Okay, let's continue. And our features that, I mean, a lot of people are asking about trusted UI. That is something we would like to look into in the future also. We have been talking about the user mode T. That's maybe not necessary if you have all the support needed in QEMU, for example. But the idea was that you should have some kind of environment that can run Trustzone on your x86 PC. And
yeah, I think that that's one of the most important things that we can do. I think when it comes to working on the Opti, it's really important that we have kind of a reference implementation of this is how to build a reasonably secure platform with some reasonable services involving, ARM trusted firmware. Opti is the one that we've chosen, the kernel, and how the pieces all interact together. And that reference platform is really valuable when we've got QEMU, FBP, Juno, and any other platforms that are fully open. Because then a developer can take it, they can build all the pieces, and they can run it. And QEMU by far is the best way to do that.
so, this slide's now about the future enhancements. Some of those we have started to work on, some, as you understood, is completed. Some is just brainstorming, we want to do it, but we don't have any solution. So it's a mix of ideas that came out from the sprint we had this summer. So, questions? Does it sound sane? Insane?
What's the current runtime memory from Opti? The memory of the runtime memory for Opti? I'm just wondering what's the current runtime memory requirement, memory footprint?
100.
Yes, so 800.
800K.
Let's say, yeah, without any extra libraries. Right now, the footprint is around 800K.
And that's all from SRAM, or it's?
No, right now what we're doing is while we are preloading the binary directly in the DRAM. This is what we're doing.
So it's running from DRAM?
Yes.
Someone said you weren't using DRAM. Yeah, you asked about that. So we are running the DRAM.
I think it's now we're relating to the previous presentation because we have different platforms and we have different setups. So we have to keep things apart here. So in Cedric's case, he's running Estes Orly board. In Sunny's case, he's an Allwinner A80. And we two here, we tend to run FVP and QEMU.
Surely the bandwidth requirements is similar on all of them, so there's not no platform with that test RAM, so how are you doing?
Some pieces of hardware can dynamically encrypt to RAM, which makes using DRAM permissible. Some pieces of hardware solve the same problem with SRAM. So whether or not you're in DRAM or SRAM is not the interesting question.
No, it's really how it's possible to do it, run it on SRAM with the RAM requirements 800K. There's no platform for that much SRAM.
It's the secure bits or the client. But when we talk about this being 800K, it's not one thing. There's secure bits and non-secure bits and client bits, but how much of it are we talking about takes up 800K? It's the secure bit, isn't it?
It's the secure bit. I think 800K is a bit more than we are actually using today. I think that was a bit too large number.
Where does it all go? Because this seems like a kind of dumb bootloader type pre-chip. Why is it taking 800K?
It's probably because, among other things, we have disabled compilation options, optimizations and stuff, to be able to debug it as easy as possible. My best guess for if we have all optimizations on would be maybe 250K.
And of that 250K, how does it break down? So 100K is the crypto library, or what's the idea?
Yeah, that's probably close to that. And then we have MMU tables, some stacks and stuff. That also takes memory.
Okay, thanks.
Also relates back to the question about reducing the footprint. I mean, today we are compiling everything, the complete cryptographic stack, everything. So if we can reduce that, we will of course get down in size also.
How much of the crypto? Sorry.
Okay, so it's 11:10, and we've got a break, and then I think we're right back in this room for the next session. Can I suggest we take a 10-minute break and pick up again at 11:20? We'll finish off some of these questions and then get on to the OPTI or to the security architecture higher level. Okay.
But the point, I think, can be removed.